Hello all, I am Priya. In this video, I am going to discuss about circular linked list. Circular linked list. In single linked list, every node points to its next node in the sequence and last node points to null. In case of circular linked list, it is a sequence of elements in which every element has link to its next element and last element has a link to the first element in the list. So here we can see that head will be containing the address of the first node, that is 1001. The last node will be having address of the first node, that is address part of the last node will be having the address of the first node 1001 again. That is, it will be forming a chain and going back to the first node. Memory representation of circular linked list. For circular linked list, in the memory, the last node of the list contains the address of the first node of the list. For example, a list containing marks of a student in 4 subjects. The start of the list is pointing to the element with the index 1 and containing 13 marks in the data part and 4 in the next part. That is, it is linked with the node that is being stored at 4th index of the list. Types of circular linked list. First type, circular singly linked list. In single circular linked list, the last node of the list holds the address of the first node, hence forming the circular chain. For example, start containing the address 100 and the elements are 10, 20, 30 and 40. We can see that address part of the last node is containing the address of the first node. Circular doubly linked list. Here in circular doubly linked list, each node will be having 3 parts. Start pointer variable will be containing the address of the first node. The previous of the first node will be containing the address of the last node, and next part of the last node will be containing the address of the first node. Operations for circular linked list. In a circular linked list, following operations can be performed. Those are insertion, deletion, display, search. So first is insertion. In a circular linked list, insertion operation can be performed in 3 ways. Insertion at beginning of the list, insertion at end of the list, inserting at specific location in the list. So insertion at beginning of the list. Suppose we want to insert a node with value 6 at the beginning, then we create a new node which we allocate memory for new node and we assign the data. And then we store the address of the current first node in the new node and then point the last node to new node. Insertion at end of the list. Suppose we want to insert a node with value 6 after the last node with value 3 in the given circular linked list. So how we'll do that? Store the address of the head node to the next of the new node and then point the current last node to new node and make new node as the last node. Insertion at specific location in the list. If we want to insert a node with value 6 after the head node with value 1 in the given list, then we'll travel to the node given node 1, point to the next of the new node to the node next to the node 1 and then we'll store the address of the new node at the next of node 1. So the second operation is deletion. In a double linked list, deletion operation can be performed in 3 ways. deleting from beginning of the list, deleting from end of the list, deleting at specific node. Deletion from the beginning of the list. To delete the first node from a circular linked list, check if the list is empty. If the list is empty, then head is equal to null, write underflow. Then we'll check the list contains only one node. If it contains one node, then delete that node and set the last node as a pointer to null. Now, if the list contains more than one node, traverse the list to find the last node, update the node's next pointer to skip the head node, effectively removing it from the list. Deletion from the end of the list. To delete the last node in a circular list, we handle the empty and single node cases. Algorithm. Step 1, if head is equal to null, then we write underflow and we directly go to step 8. Step 2, set ptr is equal to head and we'll repeat step 4 and 5 while ptr next is not equal to head. Step 4, set pre-ptr is equal to ptr. Set 5, set ptr is equal to ptr next. Step 6, set pre-ptr next is equal to head, and step 7, free ptr. Step 8, exit. Deletion from specified position of the list. To delete a specific node from a circular linked list, we handle empty list and single node cases. So for that, algorithm. Step 1, start. Step 2, store the element to be deleted. Step 3, store the position. Step 4, initialize counter c is equal to 1. Step 5, check while c is less than POS. Step 6, count the position of data to be deleted. Y is equal to x, x is equal to x link. C++. Step 7, use free to delete. Y link is equal to x link, free of x. Step 8, stop. Display. In display, the algorithm is step 1, set ptr is equal to head. Step 2, if head is not equal to null, then repeat step 3 to 4 while ptr is not equal to null. Step 3, print ptr data. Step 4, ptr is equal to ptr next. Step 5, exit. So this is how we'll display the circular linked list. For search. For search algorithm, set ptr is equal to head, means we start at the head node. Step 2, set I is equal to 0, means position counter. Step 3, if ptr is equal to null, means the list is empty. Write empty list and directly go to step 8. Step 4, if head is data is equal to item, write I plus 1 return, means the item is at position I plus 1, print the position and return. Step 5, repeat step 5 and 7 until ptr next is not equal to head. Then step 6, if ptr is data is equal to item, then write I plus 1. And then step 8, ptr is equal to ptr next and exit. Advantages of circular linked list. In a circular linked list, any node can be the starting point and traversal continuous until the first visitor node is reached again. It's useful for queue implementation needing only one pointer to the last inserted node. The front is the next of this node. Common in systems where process or applications need to be repeatedly cycled through. Example, CPU scheduling. Circular doubly linked lists are also important in advanced structures like Fibonacci heaps, and simpler to implement than more complex structures like trees and graphs. Disadvantages of circular linked list. Compared to singly linked lists, circular lists are more complex. It is possible for the code to go into an infinite loop if it is not handled carefully. It is harder to find the end of the list and control the loop. And circular linked lists don't provide direct access to the individual nodes. Applications of circular linked list. Multiplayer games use this to give each player a chance to play, and a circular linked list can be used to organize multiple running applications on an operating systems. These applications are iterated over by the OS. Circular linked list can be used in resource allocation problems, and circular linked lists are commonly used to implement circular buffers and many more. And it is also used in simulation and gaming also. Thank you.